Hi everyone, my name is Mark McGill and I'm recording this talk both for CHI on the Digital Library and for the SICSA CHI Day, and today I'll be talking about our paper, Acoustic Transparency and the Changing Soundscape of Auditory Mixed Reality. So we're all incredibly familiar with headphones as the predominant means of personal audio delivery. Headphones are occlusive, they diminish our awareness of our aural reality. They are immersive, so we're ensconced in a virtual audio experience. They're typically egocentric, so our audio space is fixed to our head, and they are near ubiquitous, being the status quo for nigh on 60 years. However, the status quo is being disrupted. Firstly, in terms of auditory headset hardware, we now have hearables, which are ear-mounted wearable computer interfaces, earables, which are augmented earbuds, and intelligent headsets, all now capable of head orientation tracking, physiological sensing, contextual awareness, and so on. And this sensing can be packed into discrete, wearable form factors. These wearables are beginning to see significant adoption, although in truth I'm not sure how many dogs wear headphones currently, but perhaps that's a question for Sean Lawson and the dog internet. And these devices are also advancing in terms of acoustic transparency, which refers to their capability to intermix real and virtual sounds. For headsets, noise-cancelling directional microphone arrays can be used to also capture and selectively incorporate surrounding audio in what is termed active acoustic transparency. However, passive acoustically transparent audio solutions are now on the market, capable of fidelity that far exceeds that of the bone conductance of the previous era by using directional speaker arrays, as you can see here at the bottom, placed around the user's neck or in the frames of a pair of glasses. So why does this matter? Well, passive acoustic transparency can be wearable, fashionable. It allows for personal, private audio spaces. It's not occlusive, so you can still theoretically hear the sounds of reality, and they typically incorporate some additional sensing, so inertial measurement units and microphone arrays currently, and so they're capable of exocentric audio experiences. So this represents quite an advancement in terms of personal audio. However, it's not just the hardware that's changing, it's the software too, specifically regarding audio spatialization when mobile. So spatial audio libraries have been developed by Google, Oculus and Valve amongst others. Here we're showing a clip from the Resonance audio library of Google, and these come complete with support for things like 3D spatialization and environmental reverberation, and even occlusion and directivity. Now, this has been driven by the boom in VR development, so typically better audio leads to better presence in virtual reality. And we know that these features have the potential to impact perception in terms of presence and externalization in VR, e.g. for externalization that the sounds appear to emanate from the world. Their use is also fairly trivial for practitioners and developers, and most importantly, most are supported natively on mobile platforms. So Resonance in particular works across Windows, Mac, iOS and Android. As a result, our ability to render virtual audio with lifelike qualities has increased dramatically, and our ability to intermix high fidelity audio with real world audio has also increased dramatically. However, there are lots of unknowns here regarding things like the impact of head track spatialization, how audio is perceived given acoustic transparency, and the intermixing of sounds of reality, and particularly across different kinds of content and experiences that we might imagine are now feasible or possible for mobile audio. So this context and a chance demo of Ken Perlin's pair of Bose frames at CHI 2019 was what led us to conduct a study looking at the impact of acoustic transparency on audio experiences. So we had two research questions here. So firstly, are audio experiences perceived differently when rendered on acoustically transparent versus occlusive headsets? And secondly, to what extent does the real-world backdrop influence the perception of virtual sounds across the headsets? We determined three factors we wanted to look at to answer these questions. Firstly, the headset type, and we chose two headsets here with an integrated IMUs for head track spatialization. They were the occlusive Bose noise-cancelling 700 headphones and the acoustically transparent Bose frames. Secondly, the perception against the real-world backdrop was another factor. So we were looking at both mobile outdoor usage, that was back when we were allowed outdoors, and usage in a controlled lab environment. And thirdly, we explored usage across 4 content types. Podcast content, and I'll play a snippet of that now.
As usual, science couldn't leave it alone, could it? No. So, Galileo stuck his telescope in, spots the moon circling around Jupiter. Typically, the next thing you know, we're stuck in the backwater of a galaxy that's among 2 trillion other galaxies with billions of planets in each in the universe.
Immersive drama content.
Now, half a century later, RAF, NATO and Soviet space program dossiers have been declassified, and audio recordings of the night in question have finally been recovered.
It's BB5, sir. Blue bottle 5, it's right there on the wing. Echoes 1, and it's the same.
Ambient content, so this was location-based audio. And audio tour guide content, so this was location-based voice clips.
The famous Grosvenor Cafe and the now internationally renowned Chip remain a defining feature. Some, like Ginty McGinty's Irish Bar, have been there a while too, almost 25 years.
Regarding demographics, there were 15 participants, 10 female, 4 male, 1 non-binary, average age of 27 years, each paid £20 for taking part. And this was across 2 sessions, so we did indoors, then outdoors for practicality, with content order counterbalanced within each of these sessions. Now, for podcast content, we found strong evidence that acoustic transparency caused greater captivation. The audio felt part of the world based on the location, i.e. both headsets exhibited this effect, so acoustic transparency didn't matter here. And for acoustic transparency specifically, it impacted the externalization and awareness of reality. For drama content, there was evidence that acoustic transparency led to the feeling of being in an active environment, and it made the audio feel more part of the world. For ambient content, acoustic transparency improved the externalization, presence and awareness of and attention to reality. And the location impacted externalization, i.e. outdoors audio felt more externalized in this case. And for tour content, there was strong evidence that audio felt more part of the world based on location when outdoors. Now, our interpretation here, well, the results weren't as clear-cut as we perhaps expected, and they certainly weren't uniform by content type or location, nor even the modality. For example, there were differences between the speech of podcast content and the speech of the audio tour guide content. So why was this the case? So different people could have markedly different interpretations about when virtual audio felt real, if at all. In interviews, we asked people about the perceived realism, and 10 participants made comments to the effect that the frames made some content appear more real. So participant 4, regarding voice content, said that with the frames, it did sound more like someone was standing beside you talking rather than just on headphone. Participant 1, when they heard thunder in the drama content when outside, said it was a little bit disturbing when I thought I could hear thunder because the audio was so good I didn't know the thunder wasn't real, so it changed my perception of what was happening. But opinions weren't clear-cut here, so some participants found the audio was equally perceived as real across headset types. So one person noted the bird song, for example, being perceived as real birds when heard on noise-cancelling headphones with the noise cancellation technology active. Regarding awareness and safety, 5 participants noted auditory isolation required more visual attention to the real world to compensate, so this is when wearing the occlusive headphones. And personal safety was noted either directly or implicitly by 6 participants as a benefit of acoustic transparency versus the occlusive headwear. So for example, participant 5 said, if I don't hear someone's behind me, that's a bit scary. And this is backed up by our questionnaire data. So broadly, participants strongly agreed that they felt safer and more secure listening to audio using the acoustically transparent headwear. For acoustic transparency specifically, participants were split down the middle regarding concerns about others overhearing their activities, and the majority of participants were of the opinion that it would be more socially acceptable to privately hear notifications instead of via the smartphone, that acoustic transparency would be a key feature in future purchase of an audio headset, that they would wear such an audio device throughout their day-to-day lives, and that they would be more likely to use audio-based applications day-to-day given acoustic transparency in their auditory headset. And regarding listening habits, over half of participants were more likely to listen to ambient audio, music, and podcasts with the presence of wearable acoustic transparency, and voice interactions also benefited as well to a lesser degree. So there are some key takeaways here. Acoustic transparency can alter the perception for specific content in terms of realism and externalization, but that alteration is not uniform across content, so we have to be careful about what we claim there. It can improve the awareness of and presence in reality, sometimes. So for immersive content, awareness seems to be moderated by the cognitive demand and attention required for that content. Acoustic transparency appears safer than opaque headsets, so particularly for the pedestrian settings we were looking at here. It could encourage voice assistant uptake, and it could lead to a resurgence of auditory interactions. People broadly seemed favourable to the idea of doing more with their audio space if they had this always available personal wearable audio device. What our work has demonstrated is that auditory augmented reality is no longer sufficient as a catch-all term for these kinds of experiences. So our paper contains definitions for auditory headsets, auditory virtual reality, auditory augmented reality that better take into account the differences between acoustically transparent and opaque headsets and the underlying intent of the mixed reality content. And regarding the types of auditory augmentations now possible, the capabilities of personal audio in terms of sensing, capture and delivery are rapidly advancing, and acoustic transparency will contribute to new and more feasible auditory augmentations. So for example, if we consider auditory extended perception, so that's experiences that enhance realities, in termed superhearing or auditory contrast enhancement, we can imagine being in a noisy room and being able to block out the conversations of others and have a conversation with a friend captured and relayed at low latency. For auditory altered reality, experiences that modify or overwrite reality, these have been referred to in the past as auditory mediated reality or warped reality. Well, MetaCookie++ is a great example of this. We could enhance the auditory experience of eating food much more trivially using such headsets. Finally, we can reflect that acoustic transparency lends users a personal, private, affordable, always available sound space. So this comes in form factors that are wearable and near fashionable. Mark Weiser discussed the concepts of invisible computing and embodied virtuality with the aim of having technology woven into the fabric of everyday life. Auditory mixed reality headsets have properties which suggest they could become an endpoint for such a vision. So from embedding a conversational virtual agent in your ear through changing your perception of an environment, providing spatial auditory prompts and reminders, to enhancing externalization in auditory experiences such as conversations or podcasts. An always available private orientation track sound space provides a lot of interesting new possibilities for HCI and for personal computing, and our results would suggest that we can anticipate people adopting this kind of technology in the near future. Thanks very much.